Hello everyone. Today let's solve the problem multiplicity, right? So this was asked in the Codeforces round 523 division 2. So you can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem, right? So what the question states here, one second, just give me a second here. Yeah. From the array A, right? So we have been given array A. From the array A, we have to count non-empty subsequences B. We have to, what we need to count? Non-empty subsequences B such that every position I, right? Such that every position I, so this I, whatever I have said, this is one index basically, right? So I'll just give here one index. I'll just give here one IDX, right? Just keep this in mind. We have to count non-empty subsequences B such that every position I that is one indexed and B of I is divisible by I, right? So and what B of I, nothing but iterated value of the B, this is divisible by I. This is divisible by I, right? So two subsequences are different if they use same if they use different index sets, right? So two subsets are different if they use different subsets, if they use different index sets, sorry, index sets, right? So two subsequences are different if they use different index sets, not subsets, sorry. So these are subsequences. Two subsequences are different if they use different index sets. So answer is modulo 1 into 10 to the power of 9 plus 7, nothing but 1e9 plus 7, right? So n has to be less than or equal to 1e5 and ai has to be less than or equal to this one is 6, nothing but 1 into 10 to the power of 6, right? So just keep this in mind. From the array A, this one, from array A, we have to count non-empty subsequences B such that for every position I, this one, for every position I, one index B of I is divisible by I, right? So B of I is divisible by I, right? So two subsequences are different if they use different index sets. Again, two subsequences are different if they use different index sets, right? So this is it for the question. Let me remove this one entirely. Yeah. So this one here, we have been given n equals 2, right? So we have been given n equals 2. This is nothing but the A, array A I was speaking, right? So from array A, we have to count the this one non-empty subsequences B, right? So this is nothing but the array A. We have to count the non-empty subsequences B accordingly with the criteria they have given in the question based on this itself. This is array A, right? So this is n, number of elements here 2, right? So we have been given number of elements n 5. See here 1 2 3 4 5 5 array elements we have, right? Same thing here. The output that we need to get here is 3 and the output that we need to get here is 13, right? So I hope the question part is completely clear, man. Now let's do one thing. Let's discuss the approach followed by the complexities and let's write the code. Initially, as usual, let's discuss the approach first. So I have considered the same first example here. So this n we have been given 2 means number of elements, and this is nothing but the array A. Array A, we have been given 1 comma 2, right? So this is fine. Output that we need to get here is 3, right? So output that we need to get here is 3, nothing but the non-empty subsequences B we have got here is 3 such that every position I is divisible by I, we got is 3. So only just keep this one thing as in mind. So we will be going with a dynamic programming, or we'll be going with this one, the approach dynamic programming basically, right? So just keep this thing in mind. So this is very important, right? So let's move on with the step-by-step explanation here. N we have been given 2 and A array we have been given 1 comma 2, which consists of the two elements 1 and 2, right? So first what we will do, as I've said, we'll be going with a DP, right? So DP of 0, initially we'll keep this one 1, right? So DP of 0, this one will initially keep this as 1. So we will be considering 1 because we have first one element, 1, right, within the array, first one. We will be taking the divisors, nothing but 1. DP of 1 equals DP of 1 plus 0. We'll be going with DP of 1 plus 0, right? So DP of 0, we have 1. This is 0. 0, DP of 1 is 0. 0 equals 0 plus 1, nothing but we will get the output 1 here. Answer 1. So subsequences we will be considering 1 here. Simple. Again, now we have to consider 2. Let's come to the 2. We have the element 2, right, after 1. So we'll be considering element 2 here. So divisors will be both this one, 1 comma 2. right? So for d equals 2, we will be going with the same formula. So similarly, similar to this one, we have went with dp of 1 equals dp of 1 plus dp of 0, previous one, right? So now we'll be going with dp of 2, when do d equals 2, dp of 2 equals dp of 2 plus dp of 1. So dp of 2, we have this one, what do we call, 1 basically, right? So this will be 1 plus 1, this will be 1 plus 1, right? So this one subsequence we got 1 here, and this one dp of 2 also we have 1, 1 plus 1 will lead to 2, so answer we will get here is 2. Answer we will be getting here is 2, because we have the devices 1 and 2, right? So we need to consider this one, dp of 1 1, dp of this one, dp of 2 is 1, dp of 1 is also 1, 1 plus 1 will lead to this one, output 2, right? So subsequence that we got here is 1 comma 2. Subsequence that we got here is 1 comma 2, right? Let's move on with the final step here. Almost. So when d equals 1, dp of 1 equals dp of 1 plus dp of 0. This one will lead to this one. Two subsequence we have here, right? So we considered for this one. So answer that we got here is 2, and we are considering for when d equals 1. We considered for d equals 2, right? So we considered for d equals 2 devices 1, we will be considering when d is 1. So this will be dp of 1 equals dp of 1 plus 0. So this will be 0 equals 0 plus 1 again, right? Sorry, dp of 1, 1 equals 1 plus 0. This will lead to 1. dp of 0, dp of 0 is 1, right? Sorry, yeah, 0 equals 0 plus 1. This one will be 1 basically. Sorry, not 1, man. 1 second. dp of 1 we are considering, right? So yeah, we have got answer 2 from the previous one. So we will be considering that answer 2, sorry. Yeah, 2 plus 1. This will lead to dp of 0. This will lead to answer 3 basically. Right, sorry, I got confused here. Subsequences again, we have the subsequences 2, right? So total good subsequences 1 and 2. This will lead to 3. Total good subsequences that will lead to 3. So this one we will return as output. This one we will return as output, answer 3. The last one we will return this one as output, right? So I got confused here, sorry man. We have to consider d equals 2 and this one d equals 1. So we will be going with a dp of 2 equals dp of 2 plus dp of 1. This will lead to 1, and the answer will be total 2, right? So and this one will be dp of 1 equals dp of 1 plus dp of 0. dp of 0 is 1, so basically the answer will lead to 3, right? So this will be 2 plus 1, this will lead to 3, right? So because dp of 1 we have got 2 here, 2 plus dp of 0 we have got 1, nothing but 3. 2 plus 1 is 3. See here, dp of we are going with dp of 2 plus dp of 1. dp of 1 we have 1, and dp of 2 will be going with 1 as well. So here 1 plus 1 will lead to 2, right? So this is fine. Same goes with the first step as well. So the last output that we got here is this one, answer 3. This one will be returning as output, right? So total good sequences, subsequences here will be 3. So the final output that we got here is 3. The final output that we got here is 3, right? So the output that we got here is 3, which is equivalent to the output they have given for the this one, for, given for the output for the example one within the question, sorry. Yeah, now as we are completely familiar with the approach, let's move on with the complexities part, right? So what will be the time complexity here? The time complexity would lead to this one, pick of n into floor of square root of a. Floor of square root of a means we'll consider real number. Suppose if we get 3.17, so we will be going with the output 3, right? Output 3, we don't need the decimals basically. So that is the reason we are considering floor of a basically, right? N into square root of a, within this brackets is nothing but floor of a, right? Just keep this in mind. Now the space complexity is nothing but because of a, because of a, right? So just give me a second. Why it is n into floor of a here? A is nothing but the max of a, we know, right? For each number we try all j less than or equal to square root of number, right? And we will be we have to handle up to 2 devices every time accordingly with the approach that we discussed. So quite obviously time complexity would be because of n into uh, floor of square root of a, right? So and the space complexity would be big of a, just a, because for the dp array, we will be considering the dp array up to this one, 1 into 1 e6, or 1 into 10 to the power of 6, right? So which stores counts for all the possible lengths, right? So overall time complexity and the space complexity for the code that we'll be writing in the future would be big of n into floor of square root of a and big of a respectively, right? So now as we are completely familiar with the complexities and the approach, we are good to write the code. Let's start writing the code. So let's start writing the code. I'll just come here. So let's import the input output package. So we'll be going with the fast input and output, right? So I'll be going with, uh, let's import the input output package. Also, we'll be going with the different utilities. I'll just import util package as well. Right, so this is fine. Now, let me go with the class name public class. So I'll just give main. In your case, you can just give another one, right? It doesn't matter. So something that's relevant. So I'll just go with the main here, right? So this is fine. Now, let's do one thing. Let me, accordingly with the question, they have strictly mentioned mod value, right? 10 to the power of 9 plus 7, or 1 in 9 plus 7. So let me consider mod value here. Static, this one final int. So this one, let me give mod equals 1, 10 to the power of 9 plus 7, right? Followed by 7 zeros here. 4, 5, 6, 7. This is 7. This is fine. And also, let's go with a max AI. Nothing but in the constraints they have given 1 into 10 to the power of 6, right? So let's allocate a bit extra for this. I'll just go with static here. Final. This one will be int. I'll just go with max and equals 1 followed by 5 zeros here. Mm, Followed by 6, 1 into 10 to the power of 6. Let's allocate a bit extra here. I'll just go with a plus 5 just for the safer side, right? So we have to go with a dp of k, nothing but we have to count the good subsequences of particular length, right? So I'll just go with here static long dp equals new long of max. This is fine. Now this is fine. Let me go with the main method here. This is also fine. Mm, Go with throws input output exception. This is also fine, man. Now within the main method, let's go with the fast input. Nothing but I'll be making use of the buffered reader here. So this one is fine. And let me make use of br equals new buffered reader new input stream reader. This one system dot done. This is fine. Now let's go with a readn. Let's go with a readn. Means here we have to read the n, right? So n is nothing but n equals 2 we have been given in the first example. We have to read that, nothing but the array length one. So I'll just go with n equals integer dot parse int here, percent of buffered reader dot read line. This is fine. So next let's do one thing. After reading n, nothing but the array length, we have to initialize the dp with -1, this one, as a sentinel meaning currently 0, right? So currently 0. So we can just articulate in the form of code in this way. You can write it in another way as well. So I'll just go with in this way. Arrays dot fill, we are just filling the dp with -1 basically in simple terms. So I'll just go with -1, right? Initially the value will be 0 basically, and dp of 0, as per the approach, we are setting this one to 1, right? So this is fine. Now we need the answer or result variable. I'll just consider answer here ans. Let me initialize this one to 0, right? So basically this answer variable, it accumulates total number of good this one subsequences, non-empty subsequences I'm speaking of, nothing but good subsequences, right? So let's make use of the string tokenizer as well, right? So we have to tokenize the entire second line. So for that one, we'll be going with a string tokenizer. So this will be string tokenizer. uh, I'll just go with st equals new string tokenizer of buffered reader dot read line. So this is fine. We are done with this part, right? So let's go with a simple for loop. We have to process each element of the array, right? So we have to go with the for loop. So this one will be int I equals 0, I less than n. Let me increment the I. So within the for loop, let's go with the current number, nothing but a of I, right? So I'll just go with int num equals integer dot path sent. So let me go with string tokenizer dot next token. So this will be next token, right? So we are done with this part. Next, let's do one thing, man. We will enumerate devices, right? So we will enumerate devices by checking up to this one, square root of number, right? By checking up to square root of number. Just give me a second. How can we articulate this one in the form of code? I can just write it in this way. Int, I'll just consider sqrt, nothing but square root variable. So this one, this has to be in the int. Let me go with the int here. Math dot square root of, let's pass the number here, right? So this is fine. The next step is we have to iterate downward. So because we have to safely update the larger length, right? So iterate downwards or reverse iteration. So anything is fine. So this will be square root j greater than or equal to 1, j minus minus. So this is fine. Within the for loop, j is a divisor and we got a pair. So this one will be if num modulo j, this is equal to 0, then int div equals num by j. This is also fine, man. Num by j. We are done with this part. So let me do one thing. First, we have to handle the larger divisor div, right? So often, which will be greater than or equal to j, right? So we need to do that. And also, if we have any subsequences of the length, div minus 1, then we can append the number, right? So we can append the number that we can do. Let's do one thing. Let me write the simple if condition. Let's see. So whether this works or not. If div is less than the value max n, then this is related to input output, and dp of div uh, minus 1, if it is not equal to minus 1, then let me do one thing. Let me assign answer to answer plus dp of div minus 1, this one modulo mod. So this is fine. This has to be capital, right? So this is fine. Now let's do one thing. Let's update the dp of div by adding dp of div minus 1, right? So let's do that. So this one will be dp of div equals, let me go with dp of div. If it is equal to minus 1, then let's display dp of div minus 1. Else let's go with dp of div, this is fine, plus dp of div minus 1, this will be div minus 1. This is also fine, man. Let's go with a mod value as well because they have strictly mentioned, right? So it should stay within 10 to the power of 9. So we have assigned mod to 10 to the power of 9, 1 followed by 7 zeros and 7, right? 10 to the power of 9 plus 7, sorry. Yeah. This is fine. Now, next let's do one thing. So I have to come out of this one entirely, right? So let me come out of this one entirely if condition. So now if the pair divisor is distinct, that is if j not equal to div, then we also handle length j, right? So we also need to handle length j. Let's see how we can handle that one. So we have to avoid the duplicates. Also, we have to go with the newly formed subsequences. These two things we have to do. First thing is if the pair divisor is distinct. Nothing but if j is not equal to div, accordingly with the approach, we have to handle the length j, right? Similarly to the previous step that we have done. So let's see the same thing. Let's write one more if condition here. Here, if j not equal to div, same thing here, similar to this one, man. If j not equal to div and j less than max n, and dp of j minus 1, if it is not equal to minus 1, then we have to avoid the duplicate. So I'll just write here answer equals answer plus dp of j minus 1. This is fine. Again, we have to consider the mod value. So it has to stay within 10 to the power of 9 plus 7. Finally, we are going with we have to avoid the duplicates and we have to go with the newly formed subsequences. That is nothing but that is the reason I have written answer equals this one, answer plus dp of j minus 1 modulo mod. So this is fine. Now we have to go with just give me a second here. Instead of dp of diff, we have to go with the dp of j, right? Similar to this step one, line number 32. For the 35, we'll just go with the dp of j equals dp of j equals minus 1. This is also fine. dp of j minus 1. This is fine. This one will be dp of j. This is fine. And the previous number dp of j minus 1. This is also fine. Yeah, we are done, almost done. We have to consider the mod value. This is fine. Mm, we are done with this step as well. I'll just come out of this one entirely here. We are left with only one thing, means we have to print the total number of good subsequences modulo mod, right? So here we have already considered mod for every step. We can just print the total number of good subsequences, nothing but answer we have considered, right? So I'll just answer variable, ans variable I have considered. So see here, this one initially we have initialized answer to 0. This one I'll just go with system out println. Let me pass as a variable. So this is it for the code. Basically, we are done with the coding part. So before checking the code with different inputs, I just want to copy paste the signature starter template. Just give me a second here. So let me come here, we paste this one, and let's concentrate on the logical part one. I'll just come here, copy the input. The output that we need to get here is 3. Let's check. So we are getting the output 3, right? So I'll just come here. Let me consider the second input. We have to get the output 13. Let's see. See here, we are getting the correct output, right? So our approach with the dynamic programming works fabulous, right? For this particular question. So it works absolutely correct. So let me copy this one. Let me come here. Let me hit on the submit button or submit code, sorry. So let me choose C here. This is problem C, right? So let me paste the code and let me hit the submit button. Let's wait for some time, man. Let's see whether this works or not for all the test cases. Let's wait for some time. Clearly see here running on test one. Mm, this might take a bit. Just let's wait for some time. Wrong on test 8. So let me check here. Let's check what is wrong. Just come here. So what mistake I have done here is, see, mod value 10 to the power of 9 plus 7 they have given. So I have given only 7, I think 1, 5, 6, 7 zeros. Yeah, this has to be 8 zeros, right? So this is fine. 1 followed by 8 zeros. and 7. This is fine. Now this is gonna be fine. And then the line number 49, instead of the modulo operator, so I have given bitwise AND operator, right? So this will absolutely give us the wrong answer for different test cases. So we have to consider all the edge cases and just one test cases correctly, right? So here, instead of the modulo, I had made use of the bitwise AND operator. Now let me copy the same thing here. Let me go one step behind. Let me paste this one and let me hit the submit button. So I hope this works for all the test cases, man. Let's see. Yeah, now this is running, right? Running on the test case, this one, 16. Let's see whether this works for all the test cases or not. So that is the reason we were getting the error, or we got the wrong answer on test 8 here, right? Mod value I had given wrong. And one more thing. So instead of the modulo operator, so this one, yeah, I had given this one, bitwise and. So yeah, you can clearly see here, right? So the verdict that we got here is accepted, which means the code works absolutely correct for all the test cases, right? So here we have went with pure dynamic programming. As I've said, we solved this problem using pure dynamic programming. Let's solve some this thing, simple problems on the dynamic programming first. Then we can go with a dynamic programming with trees, dynamic programming with bit masking and other stuff. Let's go step by step. Initially, let's solve some simple problems. This is easy, right? So I hope the solution part is completely clear, man, along with the approach and the complexities. For now, this is it. Thanks for watching, guys.